Hi, hello students. Welcome back to India's most comprehensive online learning platform, BYJU'S Exam Prep. This is Aneel Prasad Sir, and in this session, I'm going to take up a few PYQs on inter-process communication. Especially when it comes to the inter-process communication, it's a beautiful topic in entire operating system. Operating system, if you ask me which is the most beautiful topic, which is the most interesting topic, that is inter-process communication, because we can actually understand the depth of the operating system in inter-process communication, which is going to give us a lot of complexities. Okay, so let us start our session on inter-process communication PYQs. Hi, accelerate inter-concepts. Yeah, very good evening. May I know what's your name so that I'll be able to communicate directly with your name. So let me start the class right away. So this is Aneel Prasad Sir once again. For all of you guys, I don't need my introduction because for past 6 or 7 months you are continuously with me. Once again, this is Aneel Prasad Sir. I do have 13 plus years of experience and I taught everywhere in India in GATE training. So let us start this session on inter-process communication. The first question is on your screen. First of all, before I take you people into inter-process communication, first of all, let us understand something. What is this concept of inter-process communication? Okay. Hi, Abby de Villiers. Good evening. Yeah. Right now, when you talk about inter-process communication, understand something. I will start with a simple note. Okay. I will start with a simple note. Of course, I will take an example of main memory and a CPU. Okay. Where all the processes will get stored, where all the programs will get stored. All the programs of a computer system will only get stored in the main memory. Is that fine? Will only get stored in the main memory. All the process, no matter what it is, every process is going to only get stored in the main memory. The moment a process comes into the main memory, let us say a process P1 arrives into the main memory. The moment a process arrives into the main memory, operating system will treat that as an independent process. What is an independent process? An independent process is the process to which all the resources are exclusive. That means that in the simple words, when I am a process, I will be allotted with a few resources. All those resources are exclusively allotted to me, which are not shared to any other process. What are the several resources? Resources which started with the will start with the CPU time. Understand carefully, all of you. I will brush up what is inter-process, rather, what is it meant by cooperative processes. When you talk about a process, when it arrives into the process, that process will arrive into, the moment it arrives, it will be given with several resources, such as CPU time, memory space, and IO devices, and the file systems. Okay, several files will be allotted. Understand, all the resources that are allotted to the process are exclusive. These are not shared with any other process at all. Okay. The thing is, this is only true for a few processes, but for some processes, there is a need of communicating. For an example, I am one process, there is one more process, but we people want to communicate with each other. At that time, operating system will need to allot some shared resources. For an example, I just want to communicate with the other process. I am process A, there is process B. We want to exchange the information. Whenever we exchange the information, operating system can make this process communicating with each other by two means. The first one is message passing and the second one is shared memory. I hope I made it myself clear. Message passing and shared memory, as you already knew, are the techniques that are going to make two processes, rather more than one process, communicating with each other by the operating system. When it comes to the message passing, it is not that best technique which can be used by the operating system. But when it comes to the shared memory is considered to be the best technique that can make more process communicating with each other, because shared memory will allow the processes communicating with each other with more data. I just want to exchange tons of data. At that time, shared memory is the only way that I can use to communicate with the other process. Message passing will be used in between the processes to exchange a smaller information, smaller the amounts of the data. Now, in this slide, let us solve our first question. I hope all of you guys are with me. accelerate, interconcepts, or AB de Villiers? Are you with me? Shall we discuss about our first question? Say yes. I am going to give you one dimension to the inter-process communication in this very session. Shall we start? With respect to the methods, message passing and shared memory, which of the following statements are correct? Let us understand. There are two techniques which makes the process communicating with each other. The first one is message passing and the second one is shared memory. In this same light, when you talk about a shared memory and message passing, which of the following are actually true? Message passing leads to more time consumption than shared memory. This is the first statement. We need to say if it is true or not. Second one is shared memory needs only one system call during implementation. This is the second statement. And the third statement, shared memory leads to a wide range of synchronization difficulties. AB de Villiers, what is your pick? Your pick is already, I think you made your choice. That is D. AB de Villiers, you are perfectly spot on and you are correct in this light. All these three options are correct. All these three statements are actually said to be correct. I will tell you, write it down somewhere. When you talk about message passing, two processes will be able to communicate with each other by means of system calls. Let us say I am a process and there is one more process. I want to send a message to the another process. I would put it this here. There is a process A. There is a process B. Whenever process A wants to communicate with process B, it can only be done through the system calls. Hi, Neil Madhav Sahu, very good evening. Now, let us say process A wants to communicate with process B. It can only be achieved by means of a system call. You know what is a system call? System call is a service which is going to be provided to the process by the operating system in a kernel mode. So, when process A wants to send a message to process B, by using a system call called send, a message will be sent to process B. At the same time, process B, when it has to receive a message from process A, it needs to execute one more system call called receive. Not only the send and receive are only the examples through which the process can communicate with each other. But understand, there will be numerous system calls are utilized, such as send and receive, which can make two processes, rather more than one process, communicating with each other. But system call can only be executed in the kernel mode. Hi Kada. System call can only be executed in the kernel mode. What is kernel mode? When a system call is executed, a mode will need to be switched from the user mode to the kernel mode, which will take a lot of time. Again, right after the system call is executed, again mode must be switched back from the kernel mode to user mode. Okay, so obviously this is going to consume a lot of time. Message passing leads to more time consumption because message passing, write it down somewhere, can be achieved, can be implemented by system calls. When a system call has to get executed, we require to execute the system call only in the kernel mode. So there will be frequent mode switches. User mode to the kernel mode, right after the message pass happens, kernel mode to the user mode. This mode switching itself is going to take a lot of time. So for this of course leads to a lot of time consumption. Second thing is, shared memory needs only one system call during implementation. This is also correct. Now, when you talk about shared memory, understand carefully. Shared memory will be used by the operating system to establish a communication in between several processes. Shared memory has a lot of advantages over the message passing. What are the advantages? By using the message passing, the process will be able to communicate with each other whenever they do have only a simple, limited data to share. Let us say I want to share 2 MB of data with another process. This is not possible by the message passing. 2 MB is a huge data. At that time, what we can do is, we will use a shared memory, where in the shared memory, which is being used by more than one process, the process wants to send the data to the other process, will write the data, will load the data within the shared memory. The other process which wants to read the data will read it. So this is what all about shared memory technique. In the shared memory technique, we don't use extensive system calls. Okay, we'll use only one system call, just only to create the shared memory. In between several processes, operating system, during the creation of the shared memory, will use one system call called create memory. Okay, for that only we will use the system calls. So option B also is correct. The third one is shared memory leads to wide range of synchronization difficulties. Let me tell you, inter-process communication is all about the problems that we are going to face, such as race condition, such as critical section problem. You know what is critical section problem? What is race condition, right? All the total inter-process communication is just all about providing the solution to the critical section problem. Why the critical section problem we are discussing right now? Critical section problem origin is our shared memory. If there is no shared memory, there are no difficulties, there are no problems at all. Operating system will hold its head whenever two processes want to communicate with each other, because a shared memory needs to be established. Right after I establish the shared memory, then there may be a lot of chaos. There will be a lot of disturbances. There are a lot of complexities, such as race condition and the critical section problem. Okay, so we need to find out the solutions for all those problems. And option C, in that light, option C also is correct. Shared memory leads to a lot of difficulties, right? So option D is correct in this regard. Can I go to the next question? It's a simple question. Can I go to the next question? Abdibilis and Neil Madhav and Kala. Can I go to the next question? Yeah. Next question is on your screen. Srihita, Peterson's solution can't be implemented on the modern days architecture because, understand that, see, write it down somewhere. If there is a critical section problem, we need to protect the critical section. Srihita, understand. I know the operating system for you is not yet done, but understand carefully. Critical section is the piece of code which can be executed by only one process. There is process 1 and there is process 2. Understand carefully. These process 1 and process 2 are actually cooperative processes. So in process 1, there is something called a critical section. In process 2 also there is something called a critical section. What is this critical section? When process P1 and process P2 executing in their respective critical sections, they are going to access a memory region which is shared in between process P1 and P2, right? Abdibilis, correct me if I am wrong. Yes or no? This is what our critical section problem, right? Let us say myself, I am one process. Mr. Abdibilis, he is one more process. We both are cooperative process. I will example this one. What is this? Let us say there is a compiler. I am compiler. Mr. Abdibilis is loader. Got my point? Here, compiler and loader will have to get executed one after another. That too, compiler and loader need to use a shared memory region. Okay? Let us say when compiler gets executed, this compiler is going to put some data in the shared region. The output of the compiler will be used by the loader. Yes or no? So when loader gets executed, it is going to use the code that is being produced by the compiler. So first compiler should execute, followed by the loader, right? So understand carefully. This compiler will write, loader will read. Okay, so process P1 such as compiler, process P2 such as loader. When they are executing, there is a section of code which accesses critical section. Understand carefully. Only one guy can access this shared memory at once. Am I clear? Can access the shared memory at once. If both of we guys enter into our respective critical section, the shared region will be accessed at the same time simultaneously, which leads to a lot of complications. Did I make it myself clear, Srihita? Whenever there is a shared memory region which is being used by more than one process, only one process should be able to use that shared region at once. If any process wants to share region again, he needs to wait for the other process to finish. Okay, so for that reason, these critical sections must be protected by some or the other solutions. There is one solution called Peterson solution, as these guys know, is used to protect the critical section. So P1 before enters into the critical section, it will use a Peterson solution. This Peterson solution is actually the best method if it is implementable to protect the critical section. But actually the problem is Peterson solution was developed way back in 1970s or 1960s, which cannot be utilized in the modern days architecture. If you want to use the Peterson solution to protect your critical section within your application, it is not possible at all, because Peterson solution uses Peterson solution uses normal load and store instructions. Yes or no? Peterson solution actually, when access the main memory, it just uses regular instructions such as load and store. Load and store are non-atomic. Load and store can be preempted, right? So this is the very reason why Peterson solution will not work on the modern days architecture. So ABBA developers, of course, see, understand carefully, ABBA developers, where are you? Are you sleeping? Even if it is a two-process solution, let us say producer and consumer. There is a producer consumer, two process only, right? Answer me. When you talk about producer and consumer, do we have more than two process? Answer, I'm waiting. I just want to open one door for you guys. I just want to clear all the myths that are in your brain. Let us say there is producer and consumer problem right now in 2022. Even for two process, you won't be able to Peterson solution. Even to protect the critical section of the producer and consumer, you won't be able to use Peterson solution. It is simply because Peterson solution uses normal load and store instructions. I hope I made my point clear. Even for a two-process critical section, Peterson solution cannot be used in 2022 because it was the older, the method to protect the critical section, older solution. It cannot be implementable in 2022 in the modern days architecture at all. Load and store instructions are non-atomic, simple. Peterson solution uses general normal load and store instructions. It's a two-process solution. It is a wrong option. Of course, Peterson solution works only for two processes. Even in 1960s, Peterson solution cannot be used for 10 processes. Peterson solution can only be used for two processes. But now, let us in 2022, let us example that there is a producer consumer problem. Even for a producer consumer problem, although it's a two process problem, Peterson solution cannot be used because of the simple reason that's the option A, load and store instructions. And the third one is it does not satisfy bounded weighting criteria, should also be ruled out. When you talk about the Peterson solution, although we accept that it cannot work, Peterson solution will give you the best algorithmic description in such a way that it will satisfy all the criterion. Srihita, understand, whenever we want to design our solution, let us say critical section must be protected. When the critical section has to be protected, you can use any solution that are already available, or you can design your own solution. Being a programmer, it is possible. You're a good application program developer. It is still possible that you can develop your own solution. But if you want to develop your own solution, there must be three criterions must be followed. What are those? Abhidevelers, tell me. One is progress, one more is bounded weighting, one more is mutual exclusion. For this, I request you to watch my classes on operating systems in inter-process communication. I explained a lot, but if there is a solution, that solution should satisfy three criterions. First one is mutual exclusion. Mutual exclusion will allow only one process to be in the critical section. Second one is bounded weighting. Bounded weighting will avoid the starvation. A process should not enter into the critical section again and again and again as long as one more process is waiting. Okay. And the third one is the progress, right? These three must be satisfied. Peterson solution straight away will satisfy all these three criterions. Okay, this is a very good solution, but only the thing is, it is not practical in 2022. Okay, so what is our pick right now? Option A is correct. Am I right, Abhidevelers? Am I right? Option A is correct, right? It is simple. It is sensible. Option A looks very sensible at this point. Did I make myself clear? Yes. Shall we go to the next question? Yeah. A real-time operating system uses the approach of non-preemptive kernels, preemptive kernels, non-preemptive kernels with the disabled interrupts, none of the above. What is the correct option here? Neil Madhav, Abby de Villiers, of course, Srihita, as it's the first class. I can't ask her because she's just watching it. You just take your time to get into this topic. Meanwhile, I don't disturb you with my questions. Okay? Yep. Pranjal, tell me what's your pick? Real-time operating system uses the approach of what? Preemptive kernels or non-preemptive kernels? Okay? For this, I will tell you a story. In order to answer this, I will tell you a story. Okay? This story is the same example that I will explain to demonstrate what is the real-time operating system. Okay? Understand and stay with me. I will make it clear. Mr. Neil Madhav Sahu, he is correct. Preemptive kernels is perfectly right. Understand carefully. There are two things. If you want to develop an operating system, no matter who you really are, you could be Neil Madhav, you could be Pranjal, you could be Srihita or Abby de Villiers. When you want to develop your own operating system, your custom operating system, you have two ways to develop your operating system. One is preemptive kernels, one more is non-preemptive kernels. You already know kernel mode and user mode, right? Preemptive kernel meaning when a process is executing in the kernel mode, it can be preempted. Non-preemptive kernel meaning when a process is executing in the kernel mode, it cannot be preempted at all. In these two ways, you can design your custom operating system. Now understand what is the real-time operating system. Okay? In the real-time operating system, the process should be executed within a stipulated time. For that, I will give you an example of ABS. The same example that I used in my previous class while I was discussing about real-time operating system. What is ABS? Anti-lock braking system. I think you heard about the cars, right? In the cars, we use anti-lock braking system. Okay? Anti-lock braking system, if we do not get into the details, is a process. Anti-lock braking system, when executed, will avoid the accidents. Okay? But anti-lock braking system will only work when the sudden brakes are applied. Am I clear? Yes or no? Anti-lock braking. Have you heard about anti-lock braking system, Pranjal, Neil Madhav, Abby de Villiers, Srihita? Have you ever heard about anti-lock braking system or not? Yes or no? You there? I slept already. Yeah. When anti-lock braking system, understand, Srihita, what is anti-lock braking system? See, when the sudden brake is applied, the problem is tire will start sliding, the wheel will get jammed and it will slide. When wheel starts sliding, your steering will not be under your control. Your steering will be completely under your control as long as the wheels are rotating. But when you apply a sudden brake, wheels will not be under your control. Wheels will start sliding. So according to the Newton's laws of motion, inertia of rest, inertia of motion, your car will fly away somewhere to mid-accident. Sudden brake is the problem. Anti-lock braking system, when executing, will avoid the wheels from being jammed. Even when you apply the sudden brake, the car which is equipped with anti-lock braking system will allow the wheel to still rotate and get jammed. Again rotate, get jammed. During the anti-lock braking system, wheel will run and brake. Will run, again will get locked. Will run, again will get locked. So, periodically wheel will still run. So, the steering will still be under your control. So, you will be able to drive your car to the safer place. Why did I take this example? Anti-lock braking system can be used in any car as a process. If you want to equip your car with the anti-lock braking system, it can only be done by an embedded processor. The car must be supported by a processor. Okay, this processor should be supported with the real-time operating system. What is the real-time operating system? In the real-time operating system, there are some processes called critical processes. What is the critical process? ABS is the critical process. When this process arrives into the main memory, within no time it should be executed. Okay, for that, what we need to do is, we should only follow the approach of preemptive kernels. What is the preemptive kernel? Preemptive kernel will allow a process to be preempted even though when it is executing the kernel mode. Such, let us say, you applied a sudden brake. ABS immediately will get triggered. ABS will immediately come into the main memory. The moment ABS comes into the main memory, within no time, our CPU should execute. Unless the CPU executes, this ABS doesn't work. But is the CPU free? If you do have a CPU, obviously that CPU will do some or the other job. Okay, let us say that job is in the kernel mode. It cannot be preempted in the non-preemptive kernels. Your car will not be able to execute ABS within time. Yes or no? You will not have much time. The moment you apply the brake, you have the milliseconds to have the ABS triggered. Within that milliseconds, if ABS doesn't get executed, simple. You will find yourself sitting next to your grandparents in heaven or hell. Pulling your legs, fine. I hope I made my point clear. So, we use only preemptive kernels. In the preemptive kernels, even though a process is executing in the kernel mode, it will be preempted back to the main memory, and the real-time process, such as ABS, will immediately be sent to the CPU for execution. Okay, so real-time operating system will always use preemptive kernels. Did I make myself clear? Can I go to the next question? Are we done? Non-preemptive kernels is straight away to be ruled out. Non-preemptive kernel meaning I won't be able to preempt one process at all. Can I go to the next question? Yeah. Abedivilis, are we done with this? Srihita, are we done with this? Okay then. Next question is on your screen. For change, I will give you 1 minute to solve this question. I will give 1 minute to solve this question. Srihita, you just, what you do is just go through this. You just go through this. You will get to the topic directly. You don't need any introduction to solve this question. Okay? Because we just, what we need to, in order to understand, in order to get to the answer, we just need to understand the basic programming. Already I know that you people are well equipped with this basic programming techniques. Just, I don't want you to answer. Watch that. Meanwhile, the remaining people, I just want you people to give me the answers right away. Neel Madhav, what is the answer for this? The question, what's on your screen, has got what answer? And Pranjal, Abedivilis, the other guys, Neel Madhav, Pranjal, only few people are here. Why? A lot of people is showing here, but why only few people? Let me see. Yeah, fine. Anyhow, what is the answer for this? What is the answer for this? Abedivilis, may I know? May I ask you? You have 1 minute. Consider the methods used by process P1 and P2 by accessing the critical section whenever needed, as given below. The initial values of the shared Boolean variables S1 and S2 are randomly assigned. Both mutual exclusion and progress. Is that D? Abedivilis, is Neel Madhav correct? Is Neel Madhav correct or not? You there? Are you slept? Abedivilis. Pranjal, what's your pick? Srihita, can you give me a random answer? Some random answer. Fine. Let us understand. Let us understand this. See, there is process P1 and there is process P2. It is understood that only one process should be allowed to enter into the critical section. Okay. Now you just have a look at this. There is a while loop. which prevents a process from entering into the critical section or allows a process to enter into the critical section. For that, let us take the values of S1 and S2. As these are randomly assigned, we will imagine the values of S1 and S2. Okay. Let us say S1 is equal to 0, S2 also is equal to 0. Both are equal to 0. Okay. Now, when both are equal to 0, obviously, this process will get locked here. This process will not be able to enter into the critical section. That means that process P1 will be caught in the while loop. Am I correct, Srihita? Will I be able to enter into my critical section next to the while loop? No, because as the condition gets satisfied, the first process will be caught in the while loop. At the same time, second process as S1 is equal to S2 will be able to come out of the while loop and starts executing in its critical section. Okay, is that clear? Yes or no? So mutual exclusion is guaranteed. Only one process will be able to be allowed into the critical section. Okay, if it is S1 is 1, S2 is equal to 0. In this case, P1 will be allowed into the critical section, P2 will be locked in the while loop. I hope till then we are clear. So what the example what we are taking here is S1 is equal to 0, S2 is equal to 0, both are equal. Okay, now understand carefully. According to this condition, P2 will be able to enter into the critical section. But the moment the P2 comes out, what will be said by the P2? S1 is not equal to S2. So S1 is equal to 1, S2 is equal to 0. It will make S1 is equal to 1, S2 is equal to 0, or any other thing which makes S1 is not equal to S2, because that is the code that's been written here in the P2. Yes or no? If S1 is not equal to S2, then P1 is allowed into the critical section. Understand carefully. Here, the thing is, stay focused. What if P1 doesn't want to enter into the critical section? I am P1. There is one more process, P2. I don't want to enter into the critical section. Let us say Neel Madhav want to enter into the critical section. He went in because the moment straight away when he checked this, S1 is equal to 0, S2 is equal to 0. Immediately he will enter into the critical section. At the same time, P1, I don't want to enter into the critical section. I am executing in my some other code. I do not want to enter into the critical section. But the Sahu will what do you call Neel Madhav Sahu, he entered into the critical section. By the time he comes out, he has to execute one more instruction which makes S1 and S2 are not equal. Then he leaves. Here, as long as S1 is not equal to S2, it will allow only P1 but not P2 to enter into its critical section, right? At this time, as S1 is not equal to S2, P1 cannot enter, P1 can enter, P2 can never enter into the critical section at this point, right? Now understand, what if P1 doesn't want to enter into the critical section? I don't want to enter. I am executing some other code. But at the same time, Sahu want to re-enter into the critical section. No, he cannot re-enter into the critical section because S1 is not equal to S2. As long as S1 is not equal to S2, he will be caught up in the while loop. Did I make it myself clear, Sahu? Here, progress is not satisfied. Mutual exclusion is satisfied. Progress is not being satisfied. What is progress? Whenever a process wants to enter into the critical section, if there is no other process wants to enter into the critical section, the current process which wants to enter should be able to enter. Got my point clear or not? So, mutual exclusion is possible. Only one process is able to enter into the critical section according to the condition. But progress is not being satisfied at all. I hope I made my point clear. Once again, what is a progress? What do you mean by progress? Progress means if there is only one process waiting to enter into the critical section, it should be allowed to do so. Okay, because there is no other process in the system at this point wants to enter into the critical section. But here the condition has been violated. The moment process P2 comes out, it needs to wait for the P1 to enter. Unless P1 enters and sets the condition that will allow the process to enter into the critical section, there is no ever way for process P2 to again to re-enter into the critical section. I hope I made my point very clear. Sujan, yes. Okay. Can you go to the next question? Option A is correct. Progress is not being, obviously option A will rule out all the other options. Can we go to the next question? We'll take it as this. Yeah. There are several processes here. Each process P1, Pi, I is equal to 1 to 4 coded as follows. P mutex, V mutex. We're talking about semaphores here. Okay. How a semaphore to be accessed? A semaphore S value S will be initialized to 1. Right after the initialization, you will be able to access the value of the semaphore or update the value of the semaphore by using two methods. One is P of S followed by V of S. If P of S is successful, you will be able to enter into the critical section. Then you need to perform V of S. Okay. So here's, look at this. If the semaphores are used correctly and properly, there won't be any trouble whatsoever. But if the semaphores are not used properly by the programmer, those will lead to the worst outcomes. Only the thing is, you should be able to use the semaphores properly, correctly in the same order of P of S followed by V of S. If you do reverse it, there will be a lot of chaos. Here the thing is, the question is, there are several processes. Here, within this application, there are 5 processes. Okay, there is an application. Let me explain. There is this, all of you, stay focused. I don't want you to do anything. Please, do not even try for this. I will explain. Stay focused. There is an application. According to the question, there is an application. That application has altogether 5 processes. Okay, all these 5 processes are cooperative processes. Linked with each other, connected to each other, meaning all these 5 processes has a shared memory region. When this is said to be a shared memory region for all the 5 processes, obviously any of these processes can update this shared memory region. But shared memory region should be updated by only one process at a time. It can allow, any process can update the shared memory region from these 5 processes, but only one process should be allowed to access the shared memory and update it at once. Okay, so for this, let us understand. All the other processes from 1 to 4, critical section has been protected with P of S followed by V of S. Here S is just mutex. It's a semaphore mutex. Okay. But for the code P5, identical except it uses V of S in the place of P of S. So let us understand. There is a small mistake done by the programmer. He did not use the semaphores in a right way. When he did not use the semaphores in a right way, in the correct order, there will be chaos. What is the option? Abedivalis is correct. None of the above is correct option, but let me explain why. Okay, I will demonstrate with. I will demonstrate with the complete scenario. Let us say there is process P1. A process P1. Initially, we will put the semaphore mutex value. I would say mutex. Mutex value is equal to 1, right? Initially, semaphore's values are initialized to 1. Got me? When let us say process P1 wants to enter into the critical section. So what it does? It performs P of mutex. When P of S has been performed, mutex will be equal to 0. S minus minus will be performed, right? So mutex minus minus is equal to 0. So after setting it to 0, process P1 can be able to enter into the critical section. Okay, this is my critical section. Now after performing P mutex, the process P1 enters into the critical section. Now critical section has one process, that is P1. Now understand carefully. when you talk about process 5 using V of mutex followed by the critical section followed by V of mutex, that is what given in the question. For the process P5, we use critical section is being protected with, of course, semaphore value is always equal to 1, right? It is understood. What is the semaphore initial value? Semaphore's initial value will always be equal to 1. Am I right? Or do we have any other value for semaphores? A binary semaphore value will always be equal to 1. Yes or no? Yeah. So let us say process P5. Before enter into, let us say right after P1, process P5 comes into the CPU. So before it enters into the critical section, it will execute V of M. When V of M is performed, what will happen? Mutex plus plus will get performed. So by making mutex value 1, process P5 will be able to enter into the critical section. Now as the mutex value is equal to 1, let us say now there is one more process P2. If it wants to enter into the critical section, it will be able to do so, because when the mutex value is equal to 1, P of S, all the other process performing the right operations on the semaphore, that is P of mutex. P of mutex is S minus minus. When S minus minus is being performed, obviously semaphore value will get decremented. Then P2 will be able to enter into the critical section, which will make the mutex value again equal to 0. When it is equal to 0, let us say my P5 wants to come out of the critical section. Obviously it will execute V of M, making mutex value equal to 1. P5 came out of the critical section. It will allow one more process P3 to enter into the critical section by performing P of mutex by making 1 to 0. Again when P5 comes, P5 can come in. So that means that if it iterates, any number of processes can be in the critical section. Did I make it myself clear? Just it will be followed. Again P5 will come. When P5 will come, it will be equal to 1. When it is equal to 1, one more process, say P4, can be in the critical section. Yes or no? All the processes will be able to enter into the critical section because a small mistake has been committed by the application developer, because in the 5 processes, in protecting the critical section, actually he reversed the operations on the semaphores. V of M followed by the V of M, he stitched with the 5th processor critical section. So what is the option? None of the above as interpreted by the Abbe de Villiers is correct, because total 5 processes can be in the critical section at the same time. Is it making any sense? Yes or no? It makes a perfect sense. You cannot use the semaphores differently. Semaphores are to be used only in the order of the operations. When you have a critical section, use the semaphores, no problem. Use the semaphores, no problem. But initially you start with P of S. Right after you perform the critical section, you need to end with V of S. Being an application developer, your critical sections of all the process must be protected with this order of P of S followed by the V of S. Any change will lead to a worst consequences. The example is on your screen. A small minor problem, because understand carefully. Who is an application developer? You are an application developer. I am an application developer. We people are the human beings. Our tendency is to commit to the mistakes, because when we overwork, obviously we may not remember what we've been doing. When you are working late night at 12:30, of course, software job is not a regular job as a teacher, 8:30 to 4:00. No, obviously you have to work at 11:30 or 12:30 in the night. At that time you should be able to protect your critical section. Not only 5 processes, trust me, when you develop an application, there will be hundreds of cooperative processes. For all those hundreds of processes, there will be critical section. All those critical sections must be protected by the semaphores. Obviously, we may commit to some mistakes, right? But mistake is a mistake. This mistake doesn't look. It doesn't consider the factors that led us to mistake, right? Mistake is a mistake that must be corrected. Yeah, answer will be 5 for this question. Next one is on your screen. Next question is on your screen. The enter, excuse me. Yeah. The enter CS and leave CS functions to implement critical section process are realized by using test and set instruction. What is test and set instruction? Recall, all those people who are following my YouTube sessions and the app sessions, operating systems especially, they know what is test and set lock. Test and set lock is a hardware lock to protect the critical section. Tell me, what are the ways to protect the critical section? The first one is Peterson solution, right? First one is Peterson solution. But Peterson solution cannot be used in the modern days architecture. So we can use test and set lock, which is a hardware method. But a hardware method has some shortcomings. Hardware method is not transparent to application program developers. So for that we used what you call mutex locks, which is a software method. But either Peterson solution or test and set lock or mutex locks, whatever the lock that you're talking about, are having some shortcoming, which is called a busy waiting. In order to avoid the busy waiting, we introduce the semaphores. Okay, so these are the best solutions. Semaphore is perhaps the best solution among any other solution. But there are shortcomings even in the semaphore, but those can be overcome very easily. So we are talking about a test and set lock, which is a hardware lock. What is the property of a hardware lock? The property of a hardware lock is very simple. This test and set lock will satisfy only bounded waiting. Got me? You don't need to look at any other thing. Test and set lock will only satisfy bounded waiting, will allow only one process to enter into the critical section. At the same time, test and set lock will not guarantee the progress. Test and set lock will not guarantee, bigger pardon, TSL, correct me, TSL will only satisfy mutual exclusion. This is what, when we do our work, I mean, we forget a silly little things. Test and set lock will only satisfy mutual exclusion. Okay, but it doesn't satisfy bounded waiting or progress. Progress and bounded waiting will not be satisfied by the test and set lock. Understand carefully. So before enter into the critical section, it will execute. Enter, it will test and set the lock X. Then if it is successful, it will enter into the critical section. Otherwise, otherwise it will loop around. So in the same light, which are the following are possible? The above solution CS problem is deadlock free. Obviously, if mutual exclusion is satisfied, deadlock, there is no chance of deadlock. If the mutual exclusion is being satisfied by any solution, then we can say that it is deadlock free. But the solution cannot be treated as starvation free, because bounded waiting is not satisfied. A process can re-enter into the critical section as many times as it wants, as long as the lock is available. Okay, so the solution is not starvation free. The process enters CS into the FIFO order. There is no guarantee that all the process enters into the critical section in the FIFO order. And more than one process can enter into the critical section at the same time. No, it is also not possible. Only one process. By using the test and set lock, the first criteria, which is mutual exclusion, can only be satisfied. When the mutual exclusion is satisfied, only one process will be in the critical section all that time. I hope I made my point very clear. So only option 1 is correct. Option 1 is correct, right? Am I right or not? Abitabilis? Am I correct or not? Can I go to the next question? Yeah. So here only option 1 is correct. Consider the system with three. This is about deadlocks. Consider a system with 3 processes that share 4 instances of same resource type. Each process can request a maximum of k instances. Resource instances can be requested and released only one at a time. The largest value of the k will always avoid a deadlock is what? This is the question. The question is simple. System has several resources. Instance of, let us say system has several printers. There are several printers, but the number of printers is unknown according to the question. The number of printers, I'm taking the resource type as printers. Okay, and there are 3 processes. Yeah, printers also is given. Bigger pardon, there are 4 printers and there are 3 processes. Each process can request a maximum of k instances. Number of instances that are required by each process is not known as of now. Resource instances can be requested and released only one at a time. The largest value of k will always avoid a deadlock is. Now system has 4 printers, right? Let me tell you a simple way to calculate the number of instances that can be requested by each process. In order to avoid a deadlock, there is a fundamental rule to be followed. There is a fundamental rule to be followed. What is that rule? Any process, let us say there may be n number of processes. Out of this n number of processes, for one process, the system should be able to provide all the resources that it is requesting. For an instance, in order to avoid a deadlock, system needs to have sufficient number of resources. How many? For the first process, it should be able to support, it should be able to provide all the instances that it is requesting for. All. Okay. But the remaining n-1 processes, it should be able to provide the requested resource minus 1. Okay, let us say in a simple example, there are 4 processes, P1, P2, P3 and P4. All are requesting for 2 instances of resources. Okay, in order to avoid a deadlock, system needs to have the number of resources which are equal to satisfy the requirement of at least one process, that is 2, plus to satisfy the requirement of the maximum resource requirement minus 1 for the other process. So it is 1, it is 1, it is 1. If each and every resource, if each and every process is requesting for 2 resources, system will require to have at least 5 resources to avoid a deadlock. In case if we have 4 processes. Now the thing is, in the same light, what is the answer for this? What is the answer for this? Okay, let us say if each of 3 processes, there are 3 processes, what is the answer for this? Everybody please? What is the answer for this? 3 processes. Let us say each of this process requesting for 1 resource, but total number of printers are equal to 4. Obviously, 1 will not lead to a deadlock. Okay, 2. Each of the process requesting for 2 resources. So, first process can be given all the resources. Next 2 processes will get only 1 resource. Okay, next, if each of the processes, largest value of k, if each of the processes is requesting for 3 resources, each first process will be given 2. Yeah, 3 is correct. When each of the processes is requesting for 3 resources, this is correct, right? One process will be given. No, excuse me. Maximum value can only be 2, right? Correct me if I am wrong. Or what is there? There is process P1, process P2, process P3. The total number of 4 instances of the same resource. So total number of printers are equal to 4. If let us say 3 resources are being requested, 3, 3, 3. At that time, first process should be provided with 3. Next 2 processes should be provided with only 2. System need to have a total of 7 resources in order to satisfy all these, the type, right? So option B is correct. Am I right or not? System need to have the sufficient number of resources to provide at least one process total request plus total request minus 1 for the other process. Correct me if I am wrong. Option B is correct, right? Two is correct, right? Option B, 2 is correct. Neel Madhav, is 2 correct or is C correct? 3 correct. No, it is just 2. More than 2 processes, more than 2 resources are requested by any process, the system will enter into the deadlock. Yes or no? Can I go to the next question? Make it clear, Aneel Madhav, I'm waiting for your answer. Did you understand why? Or you want me to repeat it again, the previous question? Srihita, are you there? Yeah. Next question is on your screen, which is on your screen. Again, fine. That is what I want. That is what I want. Okay. Let me erase this. Erase all in. There are 3 processes: process P1, process P2, process P3. Okay. All the processes may request for some m number of resources. Okay. Now the thing is, in order to avoid a deadlock, system, our CPU, should be provided with sufficient number of resources. How many are sufficient? Simple. If these are coming up with this n each, system needs to have sufficient number of resources in such a way that it satisfies at least one process total resource requirement. The other process total resource requirement minus 1. Okay. If these many number of resources are available with the system, then we won't enter into the deadlock. Otherwise, there will be a deadlock. Okay. Let us see. The total number of resources are just equal to 4. If these are 4, the maximum possible value of n is equal to 2, right? Each of the process can request for a maximum of 2 resources. Then it will be sufficient. The 4 will be sufficient because for first process, I will give all the 2 resources. For the next process onwards, n minus 1, which is 2 minus 1 is equal to 1, which is 2 minus 1 is equal to 1, 2 plus 1 plus 1 is equal to 4, that the system has already with it. Okay, with that resource pool. But if let us say it is equal to 3, each and every process requesting for 3 resources. At that time, system needs to have at least 3 resources to support the first process, plus 2 resources to support the second process, and 2 resources to support the third process. Total 7 resources. If each process is requesting for 3 resources, the total number of resources that the system needs to have is 7, not less than 7. Otherwise, system will enter into the deadlock state. So did you get it? The maximum number of resources that can be requested by any process is equal to 2. Okay. Neel Madhav, I hope I made it clear. So let me go to the next question. Next question is on your screen. Generally, semaphores doesn't satisfy bounded weighting criterions. Obviously, bounded weighting criterion will not be satisfied by the semaphores. Simple. I told you for several times, no matter for how many times I take the semaphore topic, I can't say it's a disadvantage. I would tell you that semaphore straight away, by the definition, it wouldn't support bounded weighting. But in the same light, which of the following options are actually correct? Semaphores must be protected by the mutex locks in order to supported bounded weighting. A FIFO queue should be used to maintain the list of the blocked and waiting process on the semaphore. This is the second one. A test and set lock is used to protect the wait and signal operation. This is the third option or statement. Application developer should be able to use the sufficient number of the semaphores to ensure bounded weighting. So in order to satisfy the bounded weighting, which of the following options are actually correct? Yeah. Sujan Kumar and A.B. de Villiers, you are spot on, but you are only half correct. There is one more possible options among the options that are visible, among the options that are on the screen. Option B is, of course, it makes every sense, but there is one more option possible to have the semaphores satisfying the bounded weighting. Of course, simple. The list of the processes that are waiting for a semaphore, if they are maintained by using a FIFO queue, obviously one after another, they will enter into the critical section. Obviously, bounded weighting will get satisfied. That is, of course, that every sense will tell you the B option is correct. Ability is very good. You are spot on. If you actually know how to use the semaphores, you don't even need to maintain a FIFO queue. Tell me one thing. Is there any restriction that critical section can be protected by using only one semaphore? We can declare as many semaphores as we want, right? Yes or no? B and D are the correct options. If you know how to use the semaphores, you can declare many semaphores, and by analyzing all the permutations and combinations, you will be able to write the code, you will be able to protect the critical section in such a way that bounded weighting also gets satisfied. Yes or no? So option B, this is what this is what the mistake that we do commit to whenever we give the GATE exam. At that time, directly one answer will straight away will pull us towards us. B straight away is the correct option, but there is sometimes more than one option can be correct, right? So you should be able to choose the options wisely. So both B and D are the correct options. Okay, and yeah, the next thing is I do have two questions for you people as homework. Take a snapshot. Question number 9. Question number 9. Yeah, MSQs. Yes, when it comes to the MSQ, more than one option is correct. We should be able to be very careful. We should be very careful while we solve MSQs, okay? Because there may be one option correct in this regard. See here, I hope it is making some sense right now how to approach the GATE exam, how to appear for the GATE exam. We do have one concept called MSQs in which more than one option can be correct. Take a snapshot. It is your homework. Before I come to the next class, you should be able to finish it. And for those guys who are in my Telegram channel already, I want you people to post the answers within this Telegram group within no time. Right after I finish this class, take no time to post these answers. Are you done taking the screenshot? Can I go to the next question? Can I go to the next question? What is one more answer? One more question, huh? One more question. So sorry, this is the first part of the question. This is the second part of the question. The question is given here in the next slide. This is the second part of the question. Actually, the question, this is the data and this is the question on the data. Take the snapshot. Yeah, the final question on your screen is the 10th question. I forgot to discuss the previous questions, I guess so. Please remind me when we come back. I think on Monday we have the next class. Please remind me to discuss these questions. I just want to discuss this question because when I pick up a question to give you as a homework, those questions may be tricky. You do not fall in the trap. Just figure out everything in such a way that you come to the correct conclusion. I set you a trap for that. 10th question, straight away it is it's the dining philosopher's problem, right? Looking at that, you will be able to clearly tell me, sir, this is dining philosopher's problem. Yes or no? Nil Madhav, looking at the question, he can tell me that this is a dining philosopher's problem. Yeah. A.B. de Villiers can tell me that this is a deadlock. But I want you people to tell me which process has been locked on which semaphore. There are 5 semaphores, right? Which process is locked on which semaphore? I want you people to tell me. Deadlock is correct. Anybody can tell me deadlock. Yes, but fine. By next session, I just want you people to tell me what the option. But fine. Anyhow, B is the correct option. But why? Why deadlock occurred? Which process is blocked on which semaphore? This is for you, and you people should be able to come out of this answer. Okay, come out of this answer. That's it from the session. And Aneel Prasad Sir is signing off. If you haven't subscribed to this channel already yet, please do it, and please do like and share the session as much as possible. So that's it from the day, and good night.